left-sided limit. So we start with left-sided limit. So we say limit as x approaching a from left, function f of x, meaning that we have point x equals to a, and we are approaching a, but only from left side. So x approaching a from left side, and we see what is happening to the function. And the right side limit means something similar, but in this case x approaching a, but it's approaching point a, but only from right. Okay, so let me run a couple of examples on this and see that will make more sense. So first example will be with square root. So limit as x approaching 2 from right, square root of x minus 2. So if you look at this limit and square root of x minus 2, graph of it, looks something like this. X equals 2, square root of x minus 2. So from a graph, you can obviously see that square root of x minus 2, when x approaching 2 from right, value of function is approaching 0. If we do the same function, but now we'll approach from left, then on the left side, square root of x minus 2 is undefined, so this limit does not exist. So let me try another example on involving square roots. Limit as x approaching 2 square root of 4 minus x squared. So if you try to plug in 2 for x, you get square root of 0. So if you like, we'll look at the domain of square root of 4 minus x squared. So domain square root of 4 minus x squared. So we want to have 4 minus x squared to be at least 0. So we sketch 4 minus x squared. We find 0 is 4 minus x squared, so x equals plus or minus 2. And we figure out where positive and where negative. Plugging in, say, 3, 4 minus 3 squared is negative. Plugging in 0, we get plus, minus. So that's where a function is going to be undefined, and between negative 2 and 2, that's going to be where the domain is. So if you're approaching 2 from right, so if you're approaching 2 from right, so x approaching 2 from right, then the limit is not going to be defined because function is undefined here, so that means it does not exist. Sometimes the way I'm going to use the notation is going to be, instead of writing square root of 0, I'm going to write down square root of 0 slightly less than positive 0 minus. And square root of negative number can always that doesn't exist. That will be easier to do this way. So, and if I do another example, with the same function but now approaching 2 from left. So approaching 2 from left. So I'm staying inside of my domain. So I still have square root. So something close to 0. But I'm staying on a positive side, so it's square root of 0 plus. And square root of this positive number is defined, so my answer is going to be 0. Okay. Now let me run a few examples with absolute value. So if I want to do a couple of examples with absolute value, then first I need to write down the way I'm going to be using notation of absolute value. So if you remember, absolute value of positive number is positive number itself, absolute value of negative number is magnitude of a number. Absolute value of negative 4 is 4, absolute value of 4 is 4. So I'm going to be using definition by cases for function. So if x is positive, then absolute value of positive or 0 is the number itself. If number is negative, then I want to write down that somehow I will take only absolute value of that number, magnitude of this number. I'm going to say negative x, because negating a negative number, I'm going to get positive number. That's what I will be doing. So let me do now a couple examples of finding left and right limits with absolute value. Limit as x approaching 2, x squared minus 4, x minus 2, absolute value, and let's pick x approaching 2 from the left, x approaching 2 from left. So we want to get rid of absolute value. Firstly, I guess we can plug it in and see that we have trouble with calculating the limit 0 with 0. So we want to get rid of absolute value. So we look at x minus 2. It hits 0 at 2. So to the right from 0 is plus, from the left from 2 it's negative. So we are approaching 2 from the left side. So x minus 2 will be negative. An absolute value of negative number is going to be negated. We have to negate it. So if we use this, which means absolute value, so when x approaching 2 from left, absolute value of x minus 2 will be, we have to negate the number. So that's what we'll be doing here. So limit as x approaching 2 from left. So we'll not need that stuff anymore. I'll increase it. Negative x minus 2. X squared minus 4 we factor as x minus 2 and x plus 2. And x minus 2 and x minus 2 will be reduced. So we have negative 1 on top, plugging in 2 for x, 2 plus 2, so negative 1. Okay, so the answer for this problem is negative 1/4. Now if I do similar problem with absolute value, and I do say limit as x approaching say 3, let's put it on the right, say x minus 3 on the bottom, absolute value, and on top I'm going to write down x squared minus 9. X squared minus 9. So I try to calculate the limit right from the beginning. I get 0 over 0, so I have to get rid of absolute value somehow. So I look at the x squared minus 9. It hits 0 at negative 3 and 3. So checking where it's positive, where it's negative. Picking your test point, say 4 for interval to the right, 0 for interval between negative 3 and 3, and negative 4 here. Now we are approaching 3 from right. So when x approaching 3 from right, x squared minus 9 is positive. So absolute value of x squared minus 9 will be just x squared minus 9, because absolute value of positive number is the number itself. So that led us to get rid of absolute value. And then we factor expression on top. X minus 3 and x plus 3, and divide by x minus 3. We finish the calculations. So final answer is 6 in this case. Now the next thing I want to discuss, what is the connection between one-sided limit and two-sided limits. Two-sided limit, the regular one which we write in limit as x approaching a equals to L. That means, or it is equivalent to saying left side limit and right side limit of the function, they both also agree and equals to L. So two-sided limit exists if your left and right, they agree and they approach in the same. So let's write a quick example on this. So for example, calculate limit as x approaching 2 square root of x squared minus 4. So we're hitting square root of 0. Square root 0 is trouble, if you remember, because we want to figure out is it positive 0 or negative 0. So what we'll do, we'll calculate limit from right and limit from left. Okay, to help us to figure out what is going on, we draw a number line and x squared minus 4 equals to 0 at negative 2 and 2 plus minus plus, just by picking the sample points. So when x approaching 2 from right, we're going to get square root of 0. Because x approaching 2 from right, it's going to be positive 0. Square root of 0 plus is 0. When we approaching 2 from left, we see square root of 0 minus. We see negative number, and that does not exist, period. Now if you look to two-sided limit, right side limit insists on 0, left side limit insists on does not exist, so two-sided limit cannot exist because in order for two-sided limit to exist, both sides have to agree.